Good afternoon, my YouTube viewers. It's Crystal here. I wanted to make you a video to give you a solution to the Analytics Vidhida Agricultural Hackathon question. And this query started out to be a lot more difficult than I originally thought it was going to be. And as I go over the solution with you, you will find out. Now, I've put the solution on my GitHub account, so if you want to follow along with me, you can see what my name is in GitHub, and you can see the file, the directory that it's filed under. So this solution to the Analytics Vidhida Agriculture Hackathon, I use the random forest algorithm because I was looking on the internet, and the random forest algorithm is one algorithm that you can use to for like sampling for answers for multi-class where the other classes are very small sample rates. Now, I had originally used logistic regression because logistic regression has a function with multi-class, and I wanted to use the multi-class function, but the multi-class function did not pick up the final solution because you had three solutions. You had 0, 1, and 2. So the logarithmic regression, it picked up solution 1 and it picked up solution 2, but it didn't pick up solution 3, which in Python it would be 0, 1, and 2. And because of that, I also tried something called Smote to get it to work. And even when I use Smote, that's called like a synthetic sampling, that you insert synthetic sampling in there, it still would not pick up the final solution. And so as a result of that, I couldn't use it, even though it had a higher accuracy than the random forest, because it did not pick up the third solution, which was number 2. I couldn't use it, and I can't make a video on it because it didn't solve the problem. So that's one of the things that I wanted to explain to you. I also tried to use Smote on my random forest algorithm, and the accuracy that I got on the random forest algorithm was actually less than it was without the random forest algorithm, because I went through and I counted how many values I got on random forest without Smote, and then I counted how many values I got on the random forest with Smote. And with Smote, which was supposed to improve the accuracy, actually lowered the accuracy. So I couldn't use Smote either. So since I've explained those to you, what I'm going to do now is I'm going to go over the solution to this hackathon question. It's not the number one solution. The number one solution was about a 95% accuracy, but it's about an 80% accuracy. I'm going to try to experiment and see if I can use Keras or XGBoost to increase the accuracy, and if I'm able to use XGBoost or Keras to increase the accuracy, then I will make another video showing you the increased accuracy on this. But for the time being, we're just going to stick with random forest. So the first thing we did was we imported all of our libraries, and you see that I imported all the libraries that I thought I would need and then some. So you can see here that I had imported logistic regression, and the reason why is because I tried to do it with logistic regression and it just didn't work. It didn't pick up the third option. So, but the logistic regression is still there. But these are all the files that you need to solve this problem and then some. And then what I did was I imported the standard scaler and the min-max scaler, and I set up numbers for them. So SC was your standard scaler and MM was your min-max scaler. And the feature range, I set that up for a value of 0 to 2 because whenever we solve the problem, our output is going to be a 0, 1, or a 2. So I made the values from 0 to 2. The next thing I did was I loaded my data sets, and the data sets are on my GitHub account as well. So you can use those data sets without having to spend time on use up memory on your computer if you don't want to. Then we set up the train file, and you can see the train file. So the one good thing about the train file was it was all numeric except for there was one float in there, but it was all integers except for one float, and the ID was an object, but we're not going to be using the ID to carry out this problem anyway. The ID will be seen in the sample submission or in the submission file, but other than that, it's not going to be used in the random forest calculations. And there was one other column that's a float, and I think we have to change that to an integer. Test file is exactly the same as the train file, except the test file doesn't have the final column, which is crop damage. And you can see here in the final column, you've got a solution of 0, 1, and 2. 0 means no damage or alive. 1 means damage caused by other means, and 2 means damage caused by pesticides, because what they want to do is they want to see how much damage pesticides are causing to the crops. Here's your sample submission. So in your sample submission, you have to submit the data frame with an ID column and a crop damage column. Here's training info, tells you info on the training file, and as you can see, the ID is an object, and the number weeks used is a float, and we ended up having to change the float to an integer to do the things that I needed to do in this solution. Test file is the same as the training file, except it doesn't have a crop damage column. We did a description on the train file, so you can see all the count, mean, standard, minimum, 25%, 50%, 75%, and max. We did a describe on the test file, and it had similar information. And what we wanted to do is we wanted to check to see if we had any null values in the train file and the test file, and you can see the number of weeks used in both files, you had null values. So what I did was I filled the missing values up with the median. So you can say number of weeks used equals number of weeks used, fill in A with median. So rather than mode, so if it's like a category or an object, we would fill it up with mode, or fill it up with none, or fill it up with something like that. But because this was an actual numeric figure, I decided to go ahead and fill it out with median. And then after we filled out our blank values, filled out our null values, I wanted to test to see if we had any null values left in the two data sets. And no, there are no null values left in the two data sets. So what I wanted to see was the train file after I filled out my null values and the test file after I filled out my null values. We did a heat map so you can compare the crop damage with the other variables, because your crop damage is your dependent variables and the other variables were independent variables. So the next thing we did was we wanted to go ahead and check out damage. So we did a group by. So we did a damage group by crop damage, and I wanted to see how crop damage related to all that. And you can see we've got a table on that. So your crop damage is going to have one of three outputs, a 0, 1, or a 2. So 0 is alive, 1 is damaged by other means, and 2 is damaged via pesticides. I did a little disc plot on crop damage so you can see what it looks like. So most of the crops were alive, as you can see here on 0, and then a small amount of crops were damaged by other means, and a very small amount of crops were damaged by pesticides. And you can see that number 2 is such a low amount that it was hard to get an accurate score. And that is why people were saying to use SMOTE, SMOTE, and I didn't know what it was, but I looked it up, and what that is that puts synthetic information into the data sets. And there's another way that you can do it, like oversampling and undersampling, but the example that I saw dealt with using binary data, and the data that we've got is more like trinary, so it's multi-categorical, and so I wasn't really sure how to do it with 3 categories instead of 2, so I decided not to do anything about that for the time being. We did a violin plot on insects, and so you can see that the vast majority of insects are less than 1,000. And we did a group by of the insects, so you can see estimated insects count, and so there were a lot of insects counts here. And I don't know enough about insects to be able to group it into a small amount of insects, to a medium amount of insects, to a large amount of insects. But I suppose that what I could have done is I could have grouped it to make it a small amount, a medium amount, and a large amount, and that may have made my score more accurate. I may go back and do that and see if I can increase the accuracy. And then we did a violin chart on crop frequency to see the type of crop. So the type of crop was either a 0 or a 1. And so most of it was 0 and some of it was in 1. So we just left that as it was since it was binary anyway. The next thing we did was we did a binary chart on soil frequency, and that was 0 and 1 as well. And most of it was 0, but some of it was 1. And I didn't do anything with that column because it was only 2 variables or 2 categories. The next thing we did was we did a violin plot on pesticide frequencies. So you can see that there were 3 types of pesticides, 1, 2, and 3. The most of the pesticides were in number 3, but some of them were in number 2, and a small amount were in number 1. And then the next thing we did was we did another violin chart on number of doses, and you can see the vast majority of doses were approximately 20, but you had other doses as well. and we didn't do anything with that amount of information. But I suppose I could break that down and say, well, a small, medium, and large amounts of doses, and then that would certainly possibly make our figures a little bit more accuracy. They might give us a little bit more accuracy. Then what we did was we did a violin chart on usage frequencies. So the usage, that's number of weeks used. So that was close to 30 weeks was the most that they used the pesticides. And you can see that in the violin chart. And so again, you had anywhere up to 67 weeks that they used these pesticides. But I didn't do anything with that information either because I just left it there because it was numeric data. The next thing we did was we did a violin chart on the number of weeks that they had stopped using pesticides, and the vast majority of them were 0 weeks. And you can see that on the plot. And again, the value up to 50 weeks. So they could have gone 50 weeks without using any pesticides. And the next thing we checked was the season frequency. The bulk of the season was number 2, but there were some in number 1 and number 3. And you can see they had 3 seasons as opposed to, we normally think that we have 4 seasons, but they only have 3 seasons. And maybe it's because they don't do anything in the winter season. I'm not sure. Maybe it's too cold to do anything in the winter. Now what we did was we set up our features, and our features were all numeric data except for the ID column. And then we set up our train labels, and we reshaped the train labels. The next thing we did was we defined our X, Y, and X test. So X is train features, Y is train labels, and X test is test features. Then what we did was we scaled our X, Y, and X test. And what I did was I used the min-max scaler. I tried it. I just decided to use the min-max scaler because the min-max scaler gave you a value of anywhere between 0 and 2. And since the outcome of this problem was a 0, 1, or a 2, that is what I decided to do. I believe that when I was just starting out, I experimented with the standard scaler, but I was also experimenting with Keras, and I just couldn't get Keras to work, which is why I'm using random forest. But I'll keep experimenting with Keras and see if I can get that to work too. The next thing we did was we split our training set up into train X, val X, train Y, and val Y using train test split. And we set it up with the X and Y variable, random state of 1, and a test size of 15%. And then what we did was we checked the shape of our train X, val X, train Y, and val Y, and you can see the output shapes. Here, right here, you can see I've got the smote. I tried to use the smote. The smote, in fact, on the random forest, the smote gave a lower accuracy than without the smote, which is why I decided not to use it. But I left the smote in there. And but you notice I have it little hash marks in there just to make it a remark. So it's always a good thing to experiment with smoke and experiment with scalars to see if you get a better accuracy with or without a scalar, or see if you get better accuracy with or without smoke. In this instance, smoke didn't work. Check my random forest and random forest classifier, and we fit it with train X and train Y. We predicted it on val X, and then now we have our scoring. So on the accuracy score, we had 81%, F1 score approximately 79%, and recall score 81%. We printed our tunable parameters, and you can see the tunable parameters printed here. We created a confusion matrix, and you can see the confusion matrix created here. And then what we did here was we created an array to see how our predictions tallied up with the test variables. And so I don't know how to use this confusion matrix that well, but what I do know is when I did the logistic regression, all the values in here was 0. So that tells you that it didn't pick up on the logistic regression. It didn't pick up any of the pesticides damage. And so I thought, well, that's no good. I can't make a video on that, even though I had a higher accuracy on the logistic regression than I did random forest, because it didn't pick up any of the pesticide damage. I couldn't use it. And whenever I tried smote, I actually had less predicted pesticides than I did without smote. And so I just decided, well, I can't use this. If it's not predicting the pesticides, I can't use this. So we did another report where you can print the accuracy score, which was 81%, and we did a classification report that gives you the precision, the recall, and the F1 score, and the support of these variables or of these classes. And so the next thing we did was we did our prediction based upon the test set that we created when we broke the training set down. And I flattened those values to make it like just a one-dimensional with no array. To take the 1 out, it was flattened. And so here is our actual outcome as opposed to the predicted outcome. So here you had a predicted outcome of 1 where it was actually a 0, and here you had a predicted outcome of 0 where it was actually a 1. So it only gave you about an 80% accuracy. So we need to try to improve that accuracy, and I'm going to continue experimenting with Keras to see if I can improve the accuracy of this problem. And so we had a test file, so we predicted on the test file, and we fit the test file, and then we made a prediction on the test file. And you can see that it gave you an array, and we put this into a data frame with our ID and our crop damage, and we submitted that to Analytics Vidhya to give me an accuracy of 80%. So that's basically the solution to this Analytics Vidhya Agriculture Hackathon. So when you first looked at the question, you thought, oh, well, this is going to be easy because you don't have that much manipulation to do, because all of the columns except for the ID column were numbers, and you had no values in one column in the train file and one column in the test file. So you think, well, this is going to be easy. This is going to be a piece of cake. But then you get to the fact that the majority of the answers are going to be 0, and a small amount is going to be 1, and even a smaller amount is going to be 2. And basically what's happened is the computer is having a hard time picking up the 2 value because it's so little. So it's not the easy problem I originally thought it was going to be, and I'm going to have to continue to work on it. I'm going to try to experiment with Keras and see if I can find a solution to this problem using Keras. And then if I do, I certainly will make another video to give to you. But this code here is good code, and it does work. And if you want to use it, you're more than welcome to use it because I've got it on GitHub. If you like my video, please like, subscribe, and share. If you like the work I'm doing and you want to leave a donation, I have my email address to my PayPal account in the description. And the reason why is because I don't have enough subscribers to get monetized, and the only way I can make any money on my YouTube account is to ask for donations. But thank you so much for watching this video, and I look forward to making another video for you.